good idea if you could see a textbook definition of what an inference is. And it's simply a conclusion that's reached on the basis of evidence and reason. In other words, it's not a conclusion that I just came up to randomly. I didn't go up to Dylan and say, you know what, I think you're going to go out tonight. That's pretty random, right? They're saying that I have evidence to show that there's a reason to come up with that for a guideline. I believe that everybody in this classroom will have an A or a B at the end of the 9 weeks. How could I might come up with that reasoning?
Because you're an awesome teacher.
I disagree with that, but that's okay. Because you're smart?
Because you do more studying than other people. So when we dropped out of the boat,
Based on what? Based on previous grades. How many people have had A's and B's so far this year in my class? There you go. Everybody has their hand up. There's not one person in here that hasn't had an A or a B. I don't believe. So, go ahead. It's based on evidence or reason. I can make an inference about this class, and that's all we're going to talk about. Being able to make an inference based on data that we've collected, some kind of sample of information. And we're going to talk about the different ways that we can represent those samples. So if you look in your packet on 5.2, you're going to see that they talk about making dot plots. Okay? And we're going to complete that dot plot together. Now, the dot plot's really not what's new to you. It shouldn't be. You should have made dot plots before. The new part may be making an inference from that dot plot. So if you take a look at what they've given us, it said, after obtaining a random sample of a population, you can make inferences about the population. Random samples are usually representative and support valid inferences. Rosie asked students on the lunch line how many books they had in their backpacks. She recorded the data in this list, 261041422. Make a dot plot for the books carried by this sample of students. In step 1, it says order data from least to greatest. Well, what's the smallest number? 0. So if we're going to order them from least to greatest, then I'm going to put down 0. Then I'm going to put down 1. I'm going to put down another 1. I'm going to put down 2. How many times am I put down 2? 3 times. Then I'm going to put down 2 4s, and then a 6. Okay? It says draw a number line and from 0 to 6. Why from 0 to 6? Because that's the range. And if I'm making a dot plot, then I'm simply going to put a dot on each one of those values every time it occurs. So I'm going to put a dot above 0. I'm going to put 2 dots above 1. I'm going to put 3 dots above the 2. I'm going to put 2 dots above the 4. And I'm going to put 1 dot above the 6. Okay? Everybody understand how to make a dot plot? Simple, right? First thing you need to do is put them in order from least to greatest. Figure out where your endpoints are going to be on your number line, and then put those dots in there. By the way, same dot plot, I just copied and pasted out of the next page. Notice that the dot plot puts the data values in order. Yeah, I heard somebody's phone. You can. It wasn't a sound my phone makes, so it wasn't
sounded
mine.
like something mine makes.
My phone vibrates.
You got a
Okay.
phone?
So, take a look at the information. How are the numbers of dots you plotted related to the number of data values? What can you tell me?
That more people have two books.
No, it said, how does the number of dots that I have, the number of dots that I have, represent to the data I collected? Looking for different phrasing. I think you're right, but I'd like a different phrasing. That's not what they're looking for either. They are the same. They're not talking about the number of books. They're saying that each dot represents one person. The data that I collected is represented by one dot. One piece of data, one dot. Okay? Everybody understand what they're asking?
Yes.
Number 2. It says draw conclusions. These are the inferences that they're talking about here. Most students have, notice they want me to compare it to one book in their backpacks. Do most people have more or less? Most students have more than one. That's what they're asking you to do. Make an inference. Do they have more? Do they have less than one book? Most students have fewer than what? Most students have fewer than what? 2. Most students have fewer than 2. Look, if most students, that's got to be more than 50%, right? There's 3 dots below 2. There are 3 dots above 2. 2 ends up kind of being in the middle, right? So I can't say most have more or less than 2, right? 2 is that breaking point. So if I use 2 as the breaking point, they have fewer than 2 would be most students. Most students have between what?
0 and 6. 1 and 4. 0 and 4, 1 and 2. 4 and 2. It's 2 and 4.
Most students have between what?
2 and 4 books in their backpack.
Most students have between 2 and 4 books.
I'm a genius.
What could Rosie do to improve the quality of her data? Yeah, more people. She didn't survey enough people to have a really good sample. Okay?
Ryan.
Just turn it off.
No.
Okay. Let's look at the box plot then. How many people have done a box and whisker plot before?
Me.
Okay. Should not be something, again, should not be something that's new. You should know how to do it. But we're going to talk about how to do it so that you can get one set up. And then we're going to talk about how to make inferences from that. The number of pets owned by a random sample of students at Park Middle School is shown below. Order the data from least to greatest. What's the smallest number? 0. What's the greatest number? 9. What's next in the list? And there's 2 2s. There's what? 2 3s. 1 4. and 1
Wait, there's
5 and 1 6. Okay. You're going to put 0 at the bottom, which is where they already have it. What's going to go in this top box? 9. What's going to go in this box that's here?
2,
2. What's the next number going to be?
3,
The next number?
3,
Next number?
4,
Next number?
5,
Next number.
6.
Okay? The lower and upper quartiles can be calculated by finding the median, or that halfway point. So if I went from here to here, 3 is the what? Median. It's right slap in the middle. If I go from the middle to this end, halfway in between is this box that has 2 things in it. How would I find the median of that? 2 plus 2 divided by 2. So this is obviously going to be 2. And how would I find the median of this one? 5 plus 6 divided by 2, which would be 5.5. Okay? The lower quartile is at 2. 2 plus 2 divided by 2. The median was that number there in the middle, 3. The upper quartile, 5 plus 6 divided by 2 is 5.5. The least and greatest values were 0 and 9. Draw a number line that includes all the data values. So we draw a number line that goes from 0 at least through 9. They use 10. And obviously they're going by increments of 1. Plot a point for the values that you found in step 1. So you're going to plot a point for the lowest value. You're going to plot a point for the lower quartile. You're going to plot a point for the median. You're going to plot a point for the upper quartile. So this point is at 5.5. It's in between 5 and 6. And you're going to plot a point for the largest value.
Where did they come up with the name of?
Box and whisker.
Yeah.
Here's the box. And here's the whiskers.
But dogs and cats have whiskers, but they don't have a box face.
Well, can't tell you why they did it that way. And by the way, out of all the data things that I've ever seen represented, a box and whisker plot I've never seen printed in anything except a math textbook. I've never seen it in a newspaper. I've never seen it in a magazine. The only place I've ever seen it is inside of a math classroom. Okay? But there is some interesting things that you can do with it, because if you look at a box and whisker plot, because of the way it's organized, from here to here, percentage-wise, what percentage of my people are in this category? 25%. In fact, in each one of these little groups, there's 25% of the people surveyed. Right? So, I know that half of my people are above the 3, and half of my people are below the 3, because it's in the middle. If they want to know where most of the people are at, I can look here and say, well, most of them are above 2. Right? That'd be 75% of the people. So, a good measure for the most likely number of pets. What's the most likely number of pets? What's in the middle? 3. 50% of the students have between blank and 3 pets. Between 0 and 3 pets. Or you could have gone the other way from 3 to 9. 50% of people would have between 3 and 9 pets. Almost every student has at least what? Almost every student has at least 2 pets.
That's not plural.
Yeah, it's not plural, it should be. And they really should have done this. They should have put the S in parentheses so that they weren't specifically telling you whether it was singular or plural. Okay? That's correct. Okay. I think you're on the next page, and they're talking about how to make an inference using a proportion. By the way, if you've got a random sample and you can come up with a ratio from that sample, it's safe to say that you can make a judgment based on your sample about the rest of the people based off of that ratio. It's a good way to estimate. Would it be exact? No. Is it a good way to figure out or predict something that might happen? Absolutely. If a car lot was going to purchase a car, what's the most popular color today for a car? Does anybody know? It's not. White is the most popular color of a car today. Just happens to be. Can't answer why. Just happens to be that way. It's a statistic that silver used to be the most popular color. White is the new silver. If you were a car dealership, what would you purchase most of your cars in? White. And by the way, they probably tell you percentage-wise what colors they are. So if I knew I was going to buy 1,000 cars, I would say 50% of them I would buy would be white. 20% of them would be, and they're doing that by using a proportion. Okay? So, if you look at this, it said a shipment to a warehouse consisted of 3,500 MP3 players. The manager chose a random sample of 50 of them and found that 3 were defective. How many are likely to be defective in the whole shipment? You have to make sure that when you're setting up the proportion, that you're comparing the sample to the sample, the population to the population. Defective to defective, the whole size to the whole size. I got to compare like things. I couldn't have flipped this over so defective went to the size of the population. Wouldn't work that way. Okay? Then I'm going to substitute values into this proportion. And I believe they've actually done this there. But if they haven't, let's make sure that we know what to do. How many defective MP3s were there in the sample? 3. What was the size of my sample? 50. How many defective MP3 players are in the population? Don't know. And what am I going to put for the size of the population? 3,500. And how would I solve this? Yes? I personally would cross multiply, but you're okay doing it the way that you said. I'd take 3,500 times 3 would be equal to 50x, cross multiply, and then I would divide by what? 50. 3,500 times 3 divided by 50. And what does this come up to?
210.
But instead of just do that straight by 50.
I did it all on my
Or we
head.
just do 3500 divided by 50 to get 70. 70. You don't have to write all that stuff.
Oh. What are you going to do if you get it wrong and you haven't written anything down? Just a question. I want to know. Answer the question. What are you going to do if you don't write anything down, but you get the wrong answer?
How would you get it wrong if it's the same?
Well, I don't know. But let's say that instead of punching in 3,500 for one reason, you punched in 3,400 on a calculator. Possible. Would you be able to tell? I wouldn't. How did you get your answer? Am I going to be able to tell? What's going to happen on a test if you do it that way? And there's no way I can give you any points for it doing it that way.
But that's why you do it 2 times. To check it.
And you could make the same mistake. Or you could just write it out. I'm sorry?
It's not lazy command, it's just making it work. Because 50 times 70.
Yeah, I wouldn't have done it that way. I wouldn't have done it the way they did it. I didn't even look at how they did it. They made the denominators the same. That's why they did it. I personally would not have done it the way the book did it. What would I have done? I would have cross multiplied. Okay? Because this isn't always an exact multiple. So using 70, although it would work, right? Using 70 would work. Is this always going to evenly go into that number? No, so I don't think the method is as good. It will work, but I think it's better to use something that works all the time. Cross multiplying would always work. Okay?
Are we allowed to do it the way that I did?
There's your assignment. I want you to do 1 through 7, all of them. And then I want you to do 10 through 16, only the what? Only the evens.
That's right.